Hello everyone. I am Mrs. Shobha Nikam from Department of E&TC Engineering of AISSMS Institute of Information Technology Pune. In this video, I'll describe VHDL modeling styles in general and data flow modeling style in particular. VHDL stands for Very High Speed Integrated Circuits Hardware Description Language. It is a programming language used to model electronic circuits by using data flow, behavioral, or structural modeling styles. VHDL is an IEEE standard. This language is technology or vendor independent language. It is used for programming of FPGAs, field programmable gate arrays, CPLDs, complex programmable logic devices, and ASICs, application specific integrated circuits. VHDL supports four modeling styles: data flow, behavioral, structural, and mixed. Data flow modeling is sometimes called as concurrent modeling, and behavioral modeling is sometimes called as sequential modeling. In data flow modeling, generally when else, with select when, generate, and block statements are used. VHDL code consists of library, packages, entity, and architecture. VHDL is an IEEE standard, so it supports library IEEE. Package is a collection of functions, procedures, shared variables, constants, files, data types, data objects, subtypes, attributes, and components. Package file is often used in conjunction with a VHDL library. Some packages which are commonly used in VHDL code are Standard Logic 1164, arith, and unsigned. Entity describes number of inputs and outputs to a system. Architecture describes exact behavior of the circuitry. Standard underscore logic underscore 1164 package supports multi-valued logic, scalar standard logic, and its vector version standard underscore logic underscore vector. When we define our data type as a bit, it has only two values, either 0 or 1. But when we define our input or output as a standard logic, then it has 9 different values. It starts with U. U stands for uninitialized, X is unknown, 0 is strong 0, 1 is strong 1, Z represents high impedance, W is weak unknown, L is weak low. Meaning of weak low is output we can consider as a 0, but it is not exactly 0 volts. Weak high indicates we can consider output as a 1, but we cannot say it is a strong 1. So weak 1 is where if I'm saying 1 means 5 volt, then the output may be just above 5 volt or it may be just below 5 volts. It can be 4.8 volt or it can be 5.2, 5.1 volt. Then dash indicates don't care. Weak low and weak high permits wired and or wired or operations. Entity declaration, it is used to describe number of inputs and outputs to any system, any circuit. Syntax for entity is, first word is entity, entity name is port, input and outputs, colon, direction of input outputs, and data type. This example shows entity for 4:1 multiplexer, which has 4 data inputs, 2 select inputs, and 1 output. Here, entity name is given as mux 4:1, is port ABCD all four inputs are single bit inputs. So ABCD colon, their direction is in, their inputs, so in, and data type used is standard underscore logic. Select input is 2-bit input, so it is written on separate line S colon. Again, direction of select input is in, so in, it has more than one bit, so standard logic vector in bracket 1 down to 0. 1 down to 0 means number of bits are 2. If number of bits are 4, then we can write 3 down to 0. If number of bits are 8, then we can write 7 down to 0, or we can also write 0 to 7, or we can here in multiplexer we can write 0 to 1 also. Both ways are acceptable. Y is output, it has only one bit, so Y colon, direction is out, standard underscore logic bracket complete semicolon, end entity name. Here entity name is given as mux 4 underscore 1, so end 4 mux 4 underscore 1. Here it indicates syntax for architecture. Syntax is architecture. Architecture name. Here you can assign any name, but name must start with alphabet. Of entity name, the entity for which we are writing the architecture. For single entity, we can write multiple architectures. Is architecture declarative part. In architecture declarative part, the things which are not declared in entity, like intermediate inputs and outputs, components used in the circuitry, can be declared. See, in entity we'll have to consider our system as a black box, and we can declare only external inputs and outputs of the system. We don't consider any intermediate inputs and outputs. So all these things are declared in architecture declarative part. Then begin statement. After begin statement, architecture statement part. In architecture statement part, we can either write concurrent statements or sequential statements based on the modeling styles which we are going to use. End architecture name. Here, example of 4 is to 1 multiplexer is taken. So as already explained, VHDL code consists of library, packages, entity, and architecture. So first line is library, IEEE, to include IEEE library. Then packages. First is use, IEEE standard underscore logic underscore 1164 all. Meaning is use clause is used to insert package into a VHDL code. Second package used is underscore arith all. Third package used is standard underscore logic underscore unsigned all. Arith is used to perform operations or signed and unsigned integers. Unsigned package is used for computations of unsigned variables. Then after library and packages, next is entity declaration. As explained in earlier slide, this is entity declaration for 4 is to 1 multiplexer. Next is architecture. In architecture, we describe actual behavior of the circuitry. So architecture name, we generally prefer giving name of modeling style to the name of architecture, but you can give any name to architecture. So here I am using Dataflow modeling style, and that is why name given to architecture is Dataflow. Architecture Dataflow of mux 4 underscore 1 is. Here I am writing architecture Dataflow for entity name mux 4 underscore 1. Begin. Y. Here I am using when else statements. Y is assigned as input A when select input is 0 0. So syntax is Y is assigned as A when S is equals to 0 0, else B when S is equals to 0 1, else C when S is equals to 1 0, else D. It means for rest of the conditions Y will be D. So which are the remaining conditions here? You may think remaining condition is only 1 1, but no. Here we are using standard logic, and standard logic has 9 different values. So conditions can be weak and low, weak and high, or don't care and 0, or unsigned and 1. So for rest of the conditions, Y is assigned as D, and then end architecture name. Here architecture name is given as data flow, so end data flow. Dataflow modeling supports concurrent statements, and generally used concurrent statements in dataflow modeling are when else and with select when. In previous example, I explained how to write code using when else. Now, this code is for same 4:1 multiplexer using with select when statements. Here, library files will remain same, packages will remain same, entity describes inputs and outputs, so entity will also remain same. Only the change is in architecture. Architecture, then begin, then with S select, because we are selecting select input S, and based on selection input, output will vary. With S select, Y is assigned as, this is assignment operator, Y is assigned as A, that is first input, when 0 0, B when 0 1, C when 1 0, and D when others. So here this 0 0 0 1 1 0 and others is related to select input S. Then here you can see in diagram capital ABCD is used for inputs, for representing inputs, and in code small abcd is used. See, VHDL is case insensitive. So in entity you can declare capital letters, and in architecture you can use small letters for inputs and outputs. It will consider small and uppercase letters both. It is case insensitive. That's all for now. In my subsequent videos, I'll explain behavioral modeling style and structural modeling style. Thank you for watching.